Hello and welcome to the Portland State University Computer Science Capstone for the Spring+Summer 2021 rotation. We are Team Vegify, and the engineers who worked on this project are Brandon Altermatt, Katherine Kagawa, Max Semchuk, Mustafa Radheyyan, Nhan, Shawn Tristan and Tyde Hashimoto. Vegify is a platform to help restaurants accommodate vegan and vegetarian customers by supporting the addition of plant-based options on their menus. Through the Vegify platform, restaurants would be able to upload a photo of their menu and, based on pre-existing menu items, receive suggestions for new vegetarian and vegan substitutes, and the ability to purchase the plant-based items needed directly from the Vegify platform. For our client AppGo, building the platform would allow them to more efficiently be able to market to potential customers, build a customer base, and be the middleman between restaurants and distributors. For a restaurant owner using Vegify, Vegifying a menu becomes transparent, efficient, broadens a restaurant's customer base, and therefore can be a way for them to generate more revenue. We'll start off with a demo of our application, then describe the feature set of the project, what features we would implement if we had more time, and then finally, we'll go over how we developed the project with more technical details regarding the front and back-end implementations. So to start off, our front-end team lead, Tristan will be giving our demo.
Hi, my name is Tristan. I will be doing a demo of the Vegify site. So here we have the Vegify homepage, and this is just giving an overview for the customers of what Vegify is all about. And here we have a form page, and the customer can enter their email, name of the restaurant, and they can upload a menu of which they can get vegan substitutions for. And this is the catalog page. And on this page, you can just see the customers can buy a variety of things off of the Vegify site. And we click on one of them, we can see the price, and they can select the quantity, add it to a cart. And when we hit view cart, the customer can change the quantity or remove it if they so choose to. And when we hit checkout, they'll be redirected to a Shopify site where they can enter their payment method. And to the form page, let's just try it out with a name. I like vegans. And I would like to sort of show you guys the menu I'll be using. So on this menu, it has chicken, it has pork, milk, and beef, lots of non-vegan things. So I'll be uploading this menu. And once this is processed, it will take me to a page where it will tell me what kind of substitutions I could purchase based off of the OCR scanning. And as you can see here, has a variety of substitutions I could buy. And in addition to that, in the admin page, the admin can customize the cart for the customer. So as you can see here, it has the credentials that I've entered. And the draft page, I can enter a draft page, an email like message. So let's just say, hello, vegans rule. And on the next tab, you can see this is all the OCR suggestions. And I can sort of like create like a custom like cart for the customer. So let's say we saw fish on the menu, and we can substitute that with Beyond Meat beef crumble and vegan mayo. And then we can hit send. And in my email, I can see the message, and I can go into the cart and see that it has the items that I have added. And next, Max will be talking about the project overview.
Our project was to create a web application that takes an uploaded image or PDF of a restaurant menu and then scans it, looks through it to offer additional vegan options on the existing menu without replacing the current menu, but rather as new options for the restaurant owner to cater to more groups and people with special dietary restrictions like vegan. So the target user was a business owner or restaurant manager or somebody else that would manage the menu at any given restaurant. So we didn't want it to be complex. So that is why we created a simple web interface where they could upload a menu and not worry about learning this new technology just to offer more food to more people. So we had three primary features we implemented. The first feature was to build a way to email things easily to customers, which helped automate the generation of emails and templates that were going out to the customers with the alternative food options from the menu which they uploaded. The second feature was to actually use optical character recognition to get the text from the uploaded image and get it into the application and get it to be in a usable format that we could work with. We then offered vegan options based on certain keywords, and we were actually also able to offer their corresponding prices as listed in the Shopify application. Finally, our third feature was to build an admin dashboard for David to use to send emails. The emails were sent, they were actually done with HTML, so they would be very responsive, and it wouldn't matter if the customer opened it in a web browser or in their email client, but they would still look good. And it allows also David to review the email template before it went out to the clients. Now, off to Nhan.
So the feature one is built for the admin who can add the item substitution to the customer cart and then send an email to the customer, let them know a new suggestions. When the customer receives the email, they have the button and they click to the button and it sends them back to the Vegify site, and the customer can review the item substitution recommendation. Next, feature 2 is about how OCR works. Input the menu to the OCR and get in some keywords like cheese, steak, and burger, and then compare those keywords with the substitution tags to get a appropriate item substitutions and display it on the suggestion page so the admin can add more suggestions. Otherwise, display it on a recommendation page so the customer can immediately see the substitution results. Next, feature 3 is build the admin dashboard. Some sub-features are validate user authentication, so the list of transactions that the customers have submit their menu, so a list of item substitutions suggestions based on the OCR results. The admin is able to compose the new email content and send an email to the customer. Next, Katherine will be going over additional features.
Hi, I'm Katherine Kagawa, and these are the additional features that we also implemented. So reading and parsing CSVs, generating shopping carts, uploading and downloading files from GCP, Firestore, and PSQL, converting menus into strings, parsing those strings for their product tags, generating email HTML, styling and navigation for client pages, unit tests, and much more. And this is some of our future features, which we would have also liked to implement if we had more time, such as extending the vegan recommendations to all items versus just David's Shopify catalog, sending multiple emails at once with a one-way email client, add more unit tests, calculate prices between the recommended and original menus, optimize the OCR algorithm, for example, by associating the original item with its substitute, and I'll pass it on to Brandon.
So far, we've gone over an overview of the project and a description of the feature set, and now we'll transition into how we developed our application with more technical details, starting with an architecture overview from Brandon.
Hi, I'm Brandon, and I'll be discussing the system architecture. Our backend handles conversion of a menu from an image or PDF into text, and it parses this text to identify potential substitutions. The OCR to parse the menu is implemented using Google Cloud Vision, and we used Cloud Firestore, PostgreSQL, and GCP buckets as our databases. As you've seen, our front-end handles user-facing interactions, like browsing products, uploading menus, and performing administrative functions. We built the front end using Node.js, React, and Bootstrap. Interactions between our front end and our back end are done using serverless cloud functions for things like menu uploads and sending project recommendations. Here's a diagram displaying the different components and how they were made. User requests are sent through the Firebase host, which facilitates data transfer between the front end and back end. As you can see, both the front end and the back end interact with the Shopify store. The front end uses David's Shopify products to populate the web catalog and builds carts for customer interactions. The back end queries the Shopify module to pull products, which can be recommended based on the parsed menus. Here's an example of the workflow for the backend. We receive a user's menu from the front end and use OCR to convert the menu into a plain text string. We also pull products from the Shopify catalog and identify tags associated with each product. We then parse the menu string, looking for words that match the tags of the products from the catalog. If a match is found, then the product is added to a list, which is sent as a JSON object to the front end, once all relevant products have been identified. We use a GCP bucket to store menu items uploaded by the front end, which could then be accessed by the back end. A Cloud Firestore NoSQL instance was used to store customer carts, which include a list of product alternatives. Finally, a BigQuery instance was used to store customer information, including customer names, emails, and card IDs. That's all from me. Next, Mustafa will discuss the OCR and cloud functions.
Our current text detection algorithm uses the text and paragraph bounding boxes that are output from Google Cloud Vision OCR. The text is sequentially parsed from each of the paragraph bounding boxes. If a large portion of the text is misspelled, then the text is corrected using spell check. The text is scanned for food tag keywords, which then correspond to replacement products for our customers. We had begun to experiment with designing an algorithm which uses the existing text bounding boxes in order to create paragraph bounding boxes which are more closely gathered together. The menu on this page exemplifies our efforts in successfully grouping together all of the dishes in the menu into their respective paragraph boxes. This would enable dishes to be replaced individually rather than the whole menu being replaced as one entity. The Google Cloud Function dashboard contains our suite of backend Python and Node.js functions. Most of the functions are triggered using HTTP requests. However, the main OCR script is triggered when menus are uploaded to the Google Cloud Storage bucket location. Every function except one requires proper authentication from the caller in order to successfully execute and return a response. The one function which doesn't require authentication is the function which is required to be called to access every other HTTP function and acts as the authenticating body between the client caller and the functions. This page shows the interface of the Google Cloud OCR function. The key points to be shown are the entry point of the function, the requirements text document, the trigger type details, how the function retrieves the relevant information from the event that triggered it, and how the function interacts with the information retrieved from the event. The entry point describes the point where the function starts executing. The requirements text document shows the imported libraries or application helper resources. The trigger type shows that the function is triggered or called when an object is uploaded to the Vegify bucket. The function gets the needed information from the event variable. This information's interaction will be described on the following slide. First, the menu files are processed with OCR to retrieve an OCR output string. If the menu file that was uploaded is a document, then the PDF text extraction function is called. Otherwise, the menu file is presumed to be an image file, and the image text extraction function is called. Then, the OCR string is scanned for food tag keywords, which will match found tags with recommended menu alternatives. Lastly, the menu alternatives are uploaded to the Firestore NoSQL type database with the customer ID as the identifying document name. Next, my teammate Tyde will present the front end and security of Vegify.
So for front-end implementation, we built the website with the React library using the create React app toolchain. The reason we used React is due to previous experience the developer had the library, and the Create React App toolchain allowed us to get a working website up and running in relatively little time. Because our backend utilized the Google Cloud Platform tools, we hosted the website with Firebase, as Firebase is a hosting platform owned by Google. We thought this would be a natural choice. We hosted both the admin and client portions of the site together for simplicity's sake, although this did cause issues later on with API keys, as the bundling feature of Webpack meant that API keys would get built into the website. For our backend calls, we utilize Axios, which is very convenient for us to build in user experience through the asynchronous callback function. Since React is a library and not a fully fledged framework like Angular, we had to pick and choose which packages that we were to implement to the site. On the right is the full list of dependencies that we had. The thing was of concern was, in order for our continuous deployment to work through GitHub, every package had to be re-downloaded in order to be re-hosted. And so we had to ensure that we kept the number of dependencies down. Another issue is that the app size, since Create React App is meant for single page applications, when the site gets built, it'll be bundled into one package. And so in order to deal with that, we implemented React lazy loading to separate both the client and admin portions of the site. Another thing we found was that as site complexity increased, we ended up with naming conflicts with our styling. And so we switched over to using Sass styling with modules, which auto-generates names to help deal with the naming conflicts. Here's the overall security diagram of our website. We implemented 3 different security methods: Firebase's authentication and abstract, and Google Cloud Platform's cloud identification management system. Since Firebase authentication is an email and password-based system, we thought it would be a perfect match for the admin portion of the site, while Firebase's abstract ensures that any backend calls are made through our website only. Once a valid abstract token has been passed to our backend, Google Platform will then forward the request to the appropriate cloud function with a added security token. Now I'll pass it over to Nhan.
We're using the Shopify buyer API in React to retrieve the initial information, add the item to the cart, and get in the check IDs. To get access to the Shopify API, so we have to provide a token. And also we can request the API to get the product detail by provide the product ID, or we can request the API to get the car detail by giving the checkout IDs. So next, Shawn will be going over the development process.
As team lead, I decided to utilize an agile development process as we anticipated changing requirements from our sponsor, and this allowed us to respond and adapt quickly to those changes. We used GitHub projects for our Kanban board to keep track of our issues, and Miro to collaborate on wireframes and other diagrams. We had daily Slack stand-up with Zoom stand-up twice a week and participated in agile ceremonies throughout the quarter, such as sprint planning and retrospectives with 2-week sprints. I decided early on in the first term to split up the team into front-end and back-end sub-teams. This did not explicitly limit the engineers into these categories, but we found that picking up issues based on these teams helped keep us organized within the scope of the length of Capstone. I want to give a special thanks to my front-end lead, Tristan, and back-end lead, Max, for taking on these extra responsibilities, and for Mustafa for acting as back-end lead for the last few weeks of the term as responsibilities needed to shift. I also want to give a shout out to Tyde, who essentially acted as the front-end technical lead and made many of the design decisions for the front-end implementation. And next, Max will be covering unexpected events we encountered throughout the 2 terms.
So we did have some unexpected events. The largest unexpected event that we had was people actually getting jobs, and that really created some blockers, and we just decided to meet outside of the regular times that we were meeting in order to accommodate these people. There was also some changes that the sponsor requested, but we addressed this by communicating with the sponsor and reaching an agreement and an understanding of why certain things were done the way they were, and showing that we were actually still providing what the sponsor wanted. amongst other issues, as you see here. Now off to Katherine.
Hi, it's Katherine again, and this slide is all about sponsor feedback. So David's pretty much talking about how we did a good job breaking down the project into manageable parts in a short timeline. We also had good communication between David and team leaders. And the second part is talk about how Vegify is going to be live in a couple months. So more items will be added, customers review it, and with some final design changes, Vegify will be accessible to the public at govegify.com. Yay! And now I'll pass it on to Tristan.
Lessons that we have learned primarily go into non-technical problems, which include communicating clearly to each member, adapting to changes, and simply just not assuming things. And throughout this project, we have planned first before coding, and this really helps us avoid many issues. And if we were to redo this project, we would have more frequent and consistent meetings with our front end and back end teams individually. And next, Shawn will close out for us.
And that concludes our presentation for the Portland State University's Spring/Summer 2021 Capstone. And on behalf of the entire engineering team, we want to extend a special thanks to our sponsor, David Poole, for working with us to create a software for his company, AppGo, and to our Capstone advisor, Bruce Irvin, for all the guidance throughout these past 2 terms. Thanks for watching.